morning, everybody. We are going to do a demonstration today of vinegar and baking soda. So let's talk about vinegar first. In the US, we can buy pretty standardized distilled white vinegar, and it is printed on here as being 5% diluted to 5% acidity. In doing some research for this project, I was surprised to learn that in Europe, the standard is actually a 10% acidity. But either way, that's what we have to work with. So we're going to take an aqueous solution of acetic acid, and I'm going to measure it into my container here, and then we're going to add baking soda. Pretty standard DIY experiment, especially in homes with young kids that are doing a science project. You make a volcano and you make lava. We're not going to add the one thing that is added to that experiment, but I'll talk about that in a second. So let's get started with my vinegar. I have some markings on here on my container. I'm going to add enough vinegar to bring it up to 100 mLs. 100 mLs of acetic acid, 5%. And then we're going to use a paper towel, and I'm going to use a half a teaspoon of baking soda. And the reason we're using the paper towel is because it gives us an opportunity to do what we need to do. It delays the chemical reaction just by a little bit. And I'm going to fold this up. And then, I actually don't have a cap for this, but what I do have is a balloon. And I think the balloon will actually serve to demonstrate pretty clearly what our byproducts are. So, get this guy in there. Stuck just kind of in the top, which is good because that gives me a second for this. Oh, okay, so we're already seeing some carbon dioxide being produced. I'm seeing my balloon inflating. It didn't take very long at all. And the magic self-inflating balloon. I've only used half a teaspoon of carbon dioxide. Half a teaspoon of baking soda. So I expect we'll see that in terms of how much carbon dioxide we see generated. Agitate it a little bit. Okay, starting to see more bubbles produced in there. The balloon's definitely inflating more. Right. There you have it. All right, I'm going to set this down for a second. We'll see if that grows any more. So I wanted to talk about the ingredients that we've used here. Ingredients is what I'd call them in the kitchen. Reactants is what I'd call them in my lab. So specifically what we have is acetic acid, and we're combining it with baking soda, also called sodium bicarbonate. And ultimately these two function as an acid, and this is functioning in a slightly more alkaline state. So even though it's not a true base, it's going to act like a base in our in our experiment. So two things actually happen in our experiment. One is these products initially combine, and they will combine to form in a double replacement reaction. They will combine to form sodium acetate and carbonic acid. Carbonic acid is pretty unstable, and so it decomposes pretty quickly into water and carbon dioxide. And so let's go back to the concept of the at-home lava that you might make with a child for a science fair. So same components. However, the one difference is that detergent is added to that particular experiment, and probably some red food coloring. But the detergent actually helps to trap those CO2 bubbles, and it creates kind of more of like the liquid overflowing effect. Here, no detergent. We've actually lost CO2, which tells me there's most likely a reverse reaction going on. And I've written up some of the equation here. So we've got, we've got white vinegar, there's the formula for it, and we have the formula for sodium bicarbonate. Okay, here's the goods. What we see is that 5% acid and baking soda combine in the first step in the double replacement, and then the second step we see that decomposition of the carbonic acid pretty quickly, and all of our states and all of our products are written out below. Pretty fun at-home experiment, and I'm mostly curious about the reverse reaction that's going on because our balloon has deflated now. So that CO2 has gone somewhere, and it's probably converted back into one of the original products, or potentially back into carbonic acid. But that'd be more exploration for another day. Hope you have a good one.